Maybe the most famous name in all of mathematics, at least to high schoolers across all of America, maybe the Western world, is a guy whose name rhymes with Pythagoras. Pythagoras is famous for the classic formula which most everyone learns at some time in middle school, a squared plus b squared equals c squared, which relates the lengths of the two legs of a right triangle to its hypotenuse. But what many people don't know is that he also had a brotherhood, the Pythagorean Brotherhood, or cult of Pythagoras as some call it, settled in Crotona, Italy around 530 BC according to my sources. They formed a secret society, and Pythagoras was known as a mystic and a prophet. According to legend, Pythagoreans were vegetarians, but prohibited from eating beans. They could not stir a fire with a knife, they could not wear rings, and they had to touch the earth when it thundered. The Pythagoreans believed in the transmigration of souls, that the souls of the dead returned as animals and entered an infinite cycle of reincarnation, moving up or down through the ranks of animals and humans. The only way to escape this cycle was through purification of body and mind. As in many cults, the purification of the body was achieved through modest living, abstinence, and restraint. Pythagoras said, "Beatitude is the knowledge of the perfection of the numbers of the soul." This belief is expressed very succinctly by the Pythagoreans' motto, "All is number." But they didn't believe in irrational numbers. These are numbers we now know to exist, like the square root of 2, pi, and one called phi, the magic number. These are numbers that can't be expressed as a fraction, and when you try to write them in decimal form they go on forever and never end and never repeat. And when one of their members, named Hippasus, brought it to their attention that he thought they were wrong, legend has it that they sent him to the sea to drown him. The Brotherhood kept some rules that would be strange today, and probably were strange in the times too. But all this is a long preamble to what I want to cover today, the distance formula, which, in these particular times, can be very important for practicing safe social distancing. Oh, and by the way, has anyone ever had this thought that social distancing is the entire wrong term for what we were talking about with this pandemic? Isn't the right term that we're trying to express physical distancing and not social distancing? If we were trying to socially distance, would we even be having class right now? But, in fact, we kind of are having class right now. Well, not really. We're not all having it together. But when we come back to class, I expect you guys to have all watched this. So let's look at an example where we're trying to find the distance between 2 points on an xy graph. Those points are 2, 3 and 5, 7. I'm going to start by drawing an x and a y axis, and I'm going to plot the points that are given to me. And so my first point is going to be at 2 in the horizontal direction and 3 in the vertical direction. And my next point is going to be at 5 in the horizontal direction and 7 in the vertical direction. Now what I want to do is calculate the distance between those 2 points. I want to calculate the length of the line that connects them. If I use the Pythagorean theorem, it becomes a little bit easier than using the distance formula. I just have to draw a triangle, and I'm going to count how long each of those legs are. And that horizontal leg is 3, and the vertical leg is 4. And I set up the equation a squared plus b squared equals c squared. C squared, or c, is what I'm using x to represent. That's the long leg. That's the hypotenuse. That's the side that's opposite from the right angle in a triangle. Now the equation is going to be 3 squared plus 4 squared equals x squared. Or 9 plus 16 is equal to x squared. Which means x squared is equal to 25, which means x is equal to the square root of 25, or 5. Let's find another one, where we're now finding the distance between the points -3, 2 and 1, 0. I'm going to draw my vertical axis. I'm going to draw my horizontal axis. I'm going to count -3, which is 3 going left on the x-axis, 2 going up, and I'm going to put a point. And I'm going to find the point 1, 0, which is 1 in the horizontal direction and 0 in the vertical direction. Now I'm going to draw my triangle, and it's a right triangle, and I'm going to count how long the sides are. If I count the horizontal side, it looks to me to be 4. If I count the vertical side, it's 2. So the equation I set up is going to be 2 squared plus 4 squared is equal to x squared. When I solve that, I get 4 plus 16 is equal to x squared, which means 20 is equal to x squared, which means x is the square root of 20. Now, we haven't talked about simplifying square roots, but if I take 20, I can separate it into two factors, 4 and 5, which is like the square root of 4 times the square root of 5. The square root of 5 is one of those irrational numbers, but the square root of 4 is actually just 2. So I can replace that square root of 4 with the number 2. And I'm going to get 2 square root of 5. And if I'm curious what that number is expressed as a decimal, what it looks like as an irrational number, the square root of 20 is equal to 4.472. So you can think of 2 square root 5 as approximately 4.47. Now, since we were just talking about the standards for mathematical practice, it might be a good time for us to talk about what reasoning abstractly means. Reasoning abstractly in this case might be moving back from numbers, replacing them with letters that we could later insert any numbers in for, and seeing if we could come up with a formula. So let's see if we can find the distance between 2 points, x1, y1, and x2, y2. And I'm going to draw a graph the same way as I did before, and I'm going to make some assumptions. These assumptions don't always have to be true, but let's assume that x1 is to the left of x2, and let's assume that y2 is on the top of y1. So let's make that first point x1, y1. And let's put another point to the right and above that I'm thinking of as x2, y2. And let's just think of where these x1s and y1s are on the different axes. X1 is going to be the left point on the x-axis. X2 is going to be the right point on the x-axis. Y1 is going to be the bottom point on the y-axis, and Y2 is going to be the top point on the y-axis. Now let's think about what is that distance there, the horizontal distance between x2 and x1. Well, if those numbers were 7 and 3, you would do 7 minus 3, you would get 4. We don't know what those numbers are, but let's just call the distance x2 minus x1. And similarly, if we wanted to know the vertical distance, and we were to just place numbers in there to give us some intuition as to what the formula might be, if I had 5 and 2, I might do 5 minus 2, which is 3. Since I don't have those numbers, I'm going to leave it abstractly in the form of y2 minus y1. What I'm looking for now is the distance between those 2 points, which is the hypotenuse of that right triangle. Let's label that unknown capital D. Let's try to figure out what D equals. Well, if I'm thinking about this as a right triangle, let's think of that horizontal side as A. Let's think of the vertical side as B. And let's think of the hypotenuse as C. And now I know the formula c squared is equal to a squared plus b squared. Well, what's a? A is x2 minus x1. What's b? B is y2 minus y1. So the formula that I have is going to be d squared. D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. So d is going to equal, if I take that whole thing and I copy it Move it down a little bit. To get d by itself, I'm just going to take the square root of both sides. So my distance formula is going to equal d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared.